So good afternoon students. In previous class we are discussing about the PMMC instrument, okay, as well as the moving iron instrument. So again, so you are seeing the PMMC construction, okay. So torque equation, advantages and disadvantages, as well as in moving iron type also you having two types, moving iron attraction type and moving iron repulsion type. Okay, we are discussed in these two topics in last class. So next third instrument is electro dynamometer type instrument. Okay, see, the electro dynamometer type instrument is a transfer instrument. That means a transfer instrument is one which calibrated with DC source and used without any modifications for AC measurements. Okay, so that means first of all it uses the DC source and it will be used for AC measurements also without any modification. So that's why it is called as a transfer instrument. Okay, such a transfer instrument has a same accuracy for DC and AC measurements. Okay, whenever you have used this electro dynamometer for AC measurement and DC measurement, so whenever you are using for these two measurements, it gives the accuracy will be same. See, this is the construction of a electro dynamometer type. Okay, this is the construction of electro dynamometer. See, coming to the first of all you know about working principle. So fixed coil as well as moving coil are in series. See, coming to the construction, here you have to connecting one fixed coil. Okay, one fixed coil and this one is a fixed coil and this one is a moving coil. These two will be connected in a series. Okay, so whenever these two will be connected in series, see, therefore the direction of the current in the moving coil is same as that in fixed coil. Okay, whenever you have connecting any two sources in a series connection, at that time the current will be always same in series connection. Okay, that's why here therefore the direction of the current in the moving coil is same as that in the fixed coil. Okay, so that means this means that the direction of the magnetic field changes, the direction of the moving current is also changes. So whenever you have to change the direction of the magnetic field, okay, see here you have to use a magnet. Okay, so through this one here you have this one is a spindle inside. Okay, so upon this you have this one is a pointer and this having a scale. Okay, the torque on the moving coil will not change, rather it will be unidirectional. Okay, whenever you have to change the magnetic field value, so the direction of the current will be changes, but the torque produced on the moving coil will be same. That means here you can produce a unidirectional torque. Okay, so coming to the advantages and disadvantages of a electro dynamometer, it can be used for AC as well as DC measurements. It is easy in construction. Okay, so compared to the PMMC and the MI type, the construction of the electro dynamometer is easy. The instrument is free from hysteresis error. Okay, so there will be no hysteresis errors will be produced in the electro dynamometer. Okay, as well as the electro dynamometer having uniform scale and lightweight. Okay, this having a uniform scale and weight is also light. Okay, disadvantages. Coming to disadvantages, this cost is very high. Okay, the electro dynamometer cost is very high. Errors can occur due to friction, changes in the temperature, etc. Okay, so large errors at low power factor. Okay, so it can produce as the errors will be large and power factor will be also very low. Okay, so it gets affected by external stray magnetic fields. Okay, so internally here you have produced, so here you are using the two coils connected in series, magnetic coils. So whenever the external magnetic field will affects the electro dynamometer, so that's why it can, to protect from this external magnetic field, here shielding is essential. Okay, these are the advantages and disadvantages of a electro dynamometer. Okay. See, at start you have to see what is the ammeter and what is the voltmeter. So now you can see the range of extension of instrument. Okay, so to extend the ammeter or voltmeter, okay, any meters you have to extend that range. Okay, you can, so if suppose you have 10 amperes volt, sorry 10 volts voltmeter, so but you have to extend that range of that meter, so 10 to 20 volts. So that's why here you have to discussing about the range of instruments. So coming to the shunts. Shunts are nothing but these are used for extension of ammeter range. Okay, shunt is used for extension of ammeter. The shunt is a small resistance like a strip having minimum temperature coefficient is connected in parallel with ammeter whose range is to be extended. So shunt is nothing but whenever you have to take a one resistance. Resistance is nothing but it is like a strip of one material. Okay, any material you have to bend it into like a strip. So that is connected in parallel with the ammeter. Okay, at that time that arrangement is nothing but the shunt. Okay. Multipliers are nothing but these are used for the extension of voltmeter range. Okay, shunt is used for the extension of ammeter range and multipliers are used for the extension of voltmeter range. Okay, the multiplier is a high resistance connected in series with the voltmeter. Okay, here shunt is nothing but it having a small resistance connected in parallel with ammeter, but here the multiplier is nothing but it is a high resistance connected in series with the voltmeter. Okay, those are nothing but the shunt and multiplier. Okay, these are shunt is used for to extend the range of ammeter and multiplier is used to extend the range of voltmeter. See, this is the arrangement of range extension of ammeter. Here I am says that, so what happened to shunt is nothing but here, so across the ammeter in parallel you have to connect a one resistance, shunt resistance. See, here this is a basic ammeter. Actually this is ammeter. This ammeter having internal resistance Rm and current having Im. Okay, so that's why this is called Rm is nothing but meter resistance and Im is nothing but this meter current ammeter. So to extend this range of this ammeter, here what happened? See, here you have to connecting a one shunt resistor. Okay, here you have to connect a one shunt resistor in parallel with the ammeter. Okay, so that's why this is called RHS shunt resistance. ISH means.
Hello, madam. హలో
హలో
మేడం నేను ఝాన్సీ మేడం నాకు వీడియో రావట్లేదు మేడం.
అది నీ మొబైల్లో ప్రాబ్లం అయి ఉంటుంది నాన్న, ఒకసారి చూడు వీడియో మ్యూట్ చేసి ఉంటావు.
స్టార్టింగ్ వచ్చింది మేడం, తర్వాత కట్ అయిపోయింది మేడం, రావట్లేదు, వాయిస్ కూడా స్లోగా ఉంది.
మళ్ళీ లాగిన్ అవ్వు.
సరే మేడం, 3 times అయ్యాను మేడం, అలాగే ఎగ్జిట్ అయ్యి మళ్ళీ ఎంట్రీ ఇచ్చా మేడం.
అవునా, మళ్ళీ ఇంకోసారి చూడు, ఆయన ట్రై చేయి.
సరే మేడం.
Okay, so here RHS is nothing but shunt resistance. Okay, here ISH is nothing but the current will flow through the shunt resistance. See, whenever you have to giving a supply, so from the supply the total current from the supply is nothing but I. So here the current will be divided as ISH and IM. Okay, that means ISH is nothing but the current will flow through the shunt resistor. IM is nothing but the current will flow through the ammeter, basic meter. So here see, if you know, so here you have to connecting a shunt. Okay, to know about the shunt resistance, so here you have to take an RSH is equal to Rm by M minus 1. Here M is nothing but multiplier constant. Here M is nothing but a one constant M minus 1. See here how to find out M is M equal to I by Im. Okay, so that means I equal to, so this total current value I by Im. So otherwise here you can take formula is 1 plus Rm by RSH. Rm is nothing but here you have to meter resistance, RSH is nothing but the shunt resistance. These are the two formulas to find out this constant M. Okay, this is nothing but the extension of range extension of ammeter. Okay, here to extend the range of the ammeter, here you have to taking a one shunt resistor and this one is connected in parallel with the ammeter. Whenever you have to given a supply, so the supply current is I. Okay, so this current will be divided as ISH and IM. To find out this ISH value, you have to find RSH value, you have to find out the formula Rm by M minus 1. So here you have to find out M equal to I by Im, that is equal to 1 plus Rm by RSH. Okay, these are the formulas. If suppose here you have to extend very high values, that means you have to multi-range ammeters. If suppose you have to connect one, you have to see here in previous diagram, here you have to connect a one shunt resistor, but in this you have to connecting a number of, see, for suppose here you have to connect a more than one resistor, okay, that's why this is called, these are called as a multi-range ammeter. See, here you have to take in a 4 resistors, R1, R2, R3 and R4, okay, these 4 all at a time connected in parallel with a ammeter, okay, here you have to connecting a one selector switch, okay. So in previous RSH, so here in previous diagram only in extension range of ammeter, where you have to assume RSH value will be, you have to find out RSH, you have to take an RM by M minus 1. So here also you have to find out RM1 value, you have to take in formula RM, meter resistance, by M1 minus 1. Okay, this is the constant of this resistance. Okay, R2 means RM by M2 minus 1 and so on. So here see M1, M2, M3 are shunt multiplying powers for current I1, I2, I3 etc. Okay, so that is nothing but here these constants are called M1, M2, M3 are called as shunt multiplying powers for the currents I1, I2, I3 and so on. Okay, na? So this one, those are the formulas for extension range of ammeter. Coming to the range extension of voltmeter. See, here I am says that previously. So how to extend the range of voltmeter? You have here you have to connecting a one series one resistance in series with the resistance with the voltmeter. So that is nothing but the range extension of voltmeter. Here basic meter, here this meter will be taken as, here you have to take a voltmeter and here you have to connecting a one series resistance in series with this meter. Okay, so multiplier resistance, that means this is called a multiplier. Okay, RS equal to RM into M minus 1. So here where M multiplying factor M equal to V by Vm. V is nothing but this one. Okay, supply voltage whatever you have to given is nothing but the, here you can assume V. So Vm is nothing but the meter resistance. Okay, at that time multiplying factor M equal to V by Vm. Okay. Similarly, so in previous you have to see the multi-range ammeter. Similarly here you have to multi-range voltmeter. See, in multi-range voltmeter you have to take in a 4 resistors. Okay, R1, R2, R3 and R4. Okay, these 4 resistors are connected in a parallel. Okay, so one way this total parallel connection is connected in series with the basic meter. So here the basic meter is nothing but a voltmeter. Okay, see here, so here also same one selector switch. So whatever resistance you have to connect it, at that time this switch is connected to V1. If suppose you want to V2, this resistance is connected in series with this meter. So at that time the switch is acting at V2 like this. So that's why here you can choose a one selector switch. Okay, so here R1, how to find out R1 by V1? Okay, the supply goes to R1, V1 by Im, this basic meter resistance minus Rm. Okay, these are the formulas to find out these multiplier values. Similarly, R2 means, R2 is nothing but here the supply voltage is V2, V2 by Im minus Rm. Similarly, whenever you have to find out the R3 value, so at that time here you can write V3 by Im minus Rm. Similarly, if you want R4 value, at that time here you can write V4 by Im minus Rm. Okay, so that is the multi-range voltmeters. See, here we have one small example. Okay, see, here a moving coil ammeter reading up to 1 ampere has a resistance of 0.02 ohms. Okay, how could the instrument be adapted to read current up to 100 amperes? That's why see here given that full scale deflection current of the ammeter, Im value given as 1 ampere. Line current to be measured. So the current which is to be measured will be 100 amperes. Resistance of ammeter will be given as 0.02 ohms. Let required shunt resistance. Now you have to find out the shunt resistance RSH value. So how to find out RSH value? To find RSH value in ammeter. Ammeter, the formula is Rm by m minus 1. So directly here you have given Rm, but here don't know m value. So at the time to find out the m value, what is the formula? I by Im. So Im is nothing but 100. So the current which is to be measured is 100 amperes. Im is 1 ampere. So at the time the m will becomes 100. Okay. So at the time the RSH is equal to Rm by m minus 1 equal to 0.02 by. So Rm value given in the problem will be 0.02 ohms. So that at the time 0.02 by 100 minus 1. Okay, at the time the value will become 0.000201 ohms. Okay, so this is a small 2 marks problems. Okay. Similarly, that is for the problem for ammeter. Similarly for voltmeter, see, a moving coil voltmeter reading up to 20 millivolts has a resistance of 2 ohms. Okay, so the resistance will be 2 ohms. How this instrument can be adapted to read voltage up to 300 volts. Okay, so here you have to find out 300 volts. See, voltmeter resistance Rm equal to 2 ohms, full scale voltage of the voltmeter Vm equal to 20 millivolts will be given. So this 20 millivolts will be converted into the volts. So at that time here you can write 0.02 volts. So the voltage to be measured is 300 volts. So, but here the series required RSC. RSC value, how do you have to find out RSC value? RSC equal to Rm into m minus 1. But here how to find out m value? M equal to V by m. So V value in the problem, the V value will be given as 300, Vm value will be 0.02. So at that time the m value will becomes 15,000. So at that time RSC equal to Rm into m minus 1. So Rm value will be given as 2 ohms. M value will be given as, here you can get m value will be 15,000. So at that time you can write 2 into 15,000 minus 1. So at that time the value will becomes approximately 30,000 ohms. 30,000 ohms means here you can write 30 kilo ohms also. In kilo ohms you will take. So 29,998 is nothing but it is approximately equal to the 30,000. Okay. See, up to now here you can discussing the what is the measurement. Okay, so to find out that measurement, here you are using a one instrument, and what is the instrument and what is the essential required for the instrument. See, one instrument will be working, there will be compulsory 3 torques will be acting. So those are the deflecting torque, controlling torque, damping torque. Okay, how these 3 torques will be produced we are discussing in previously, and what are the types of meters. Here you have to discussing the PMMC, moving iron type, okay, as well as the electro dynamo meter. And here you have to see the what is ammeter and what is voltmeter, and how to extend the range of ammeter, okay, and how to extend the range of voltmeter. Here, these are discussed up to now. So this is total one part in the first unit. So the remaining half part is total about CRO. CRO is nothing but cathode ray oscilloscope. CRO is nothing but this instrument you are seeing in the EDC lab. Okay, so in EDC lab you have to in either half wave rectifier, full wave rectifier, or PN junction diode. Any waves will be represented on the CRO. Okay, so see. And this is the construction of a CRO. Inside the construction is like, so here you have to see, this is the CRO. Okay, this is the CRO we are seeing in the laboratory, EDC laboratory. So under our electrical labs also there is a need of CRO in some measurements lab, power electronics lab. Okay, so the total waveforms are seeing in the CRO. Okay, so this is called as a cathode. CRO is nothing but a cathode ray oscilloscope. Okay, so this is the construction of a CRO. See, this having a one phosphorus tube. In that phosphorus tube you have the 2 plates, vertical deflecting plates, horizontal deflecting plates. Okay, so here you have to supply, okay, this total will be, sorry, this total construction, this total is a one tube, phosphorus tube, and is having a vertical deflection plates, this having a horizontal deflection plates, this phosphorus, this total up to this construction will be called as CRT. CRT is nothing but cathode ray tube. Okay, CRT is the heart of CRO. Okay, the main part in CRO is nothing but CRT. Okay, that means the total process will be done in the CRT. Okay, this is a total CRT. So through this you have to connect a delay line, vertical amplifier, okay, horizontal amplifier, time based generator, trigger circuit, like this. This is a LC. See, we are seeing in the diagram. So the cathode ray oscilloscope consisting of a black, those are vertical amplifier, delay line, trigger circuit, time based generator, horizontal amplifier, cathode ray tube and power supply. So the cathode ray tube, CRT is the heart of CRO. Okay, see, vertical amplifier. Again I will later explain the operation. First see what is the purpose of these different blocks. Okay, first of all, vertical amplifier. It amplifies the input signal which is to be displayed on the screen of CRT. Okay, so generally you are seeing the waveforms, signals. Okay, signals will be displayed on the screen. Okay, we are seeing. So it amplifies the input signal. Okay, whatever these input signals will be are given, that signals will be amplified. Amplification is nothing but it strengthening the input signal. Okay, and that means it increases the strength of the input signal which is to be displayed on the CRT. So whatever the signals will be displayed on the CRT, okay, that signals will be amplified by using the vertical amplifier. Delay line is nothing but it provides some amount of delay to the signal. Okay, which is to be see, first of all I will explain in her operation. See, so this is CRO, this is CRT. Here CRT you have to display the signals. See, this is the phosphorus electron gun. Whenever you have to, so this is the electron gun. So see, this having a one material. Okay, so either phosphorus or anything. Whenever you have to giving the supply, this one emits the electrons. Okay, so these electrons will move along this direction. So whenever it reaches the vertical deflecting plates, so on this way, whenever the electrons will reaches on this way, so whenever it comes to the vertical deflection plates, at that time they can deflect up and down. Vertical means up and down. So here see, here you can signal, see, up and down, left and right, and that means here the signal will come from the horizontal direction, vertical direction. Okay, so here the in vertical direction the signal will be displayed because of the vertical deflecting plate. On the horizontal plane, so the signal will be displayed due to the horizontal plates. See, coming to the here, so the electron gun emits the electrons. Electrons is nothing but some amount of charge, okay, some amount of amplitude. Whenever it reaches the vertical deflection plates, these are moves up and down. Okay, that means at that time you have to get the signal in the vertical axis. Okay, so whenever again when the signal is coming to the horizontal deflection, these are the horizontal deflection plates. Whenever the signal will coming to the horizontal deflection plates, so at that time the signal will move to and fro. Okay, so at that time it will be cause the signal to produce on the horizontal here like this x axis. So vertical means y axis and horizontal means x axis. So at that time it moves up and down, to and fro, and finally here this is a screen. On the top you have to see now this is screen. Okay, this is nothing but a phosphorus screen. See, this is a phosphorus screen. So at that time this total electrons will emit on this spot. Okay, here luminous spot. So whatever the spot you have to observe, thus it is here nothing but. Okay, so that means that the wave will be produced in the here. Okay, so whenever the electron gun will be heated, so at that time it releases a electron beam. Electron beam is nothing but electrons will be moving on the way, vertical deflection plate, horizontal deflection plates, and finally this will be displayed on the phosphorus screen. Okay, so at that time here finally you have to see the signal spot here. Okay, so This is the total, this part is called CRT. That means the total operation of the CRO is total done in the CRT. Okay, that's why here the CRT is called as a heart of CRO. Okay, so at that time this total signal will be displayed on the here. So see, two okay, so here I will say that the vertical deflection plates means the signal will be deflected vertically up and down. So that means to give the supply to this vertical plates, here you have to see first input signal, the signal which is given, okay, input signal is given to the vertical amplifier. So from this delay line, so delay line means, see, if suppose the signal, if suppose any horizontal plates, vertical plates, if suppose first horizontal plates will be activated, at that time the signal will be displayed on the horizontal section. So at a time the signal will be coming from the here vertical amplifiers. At the time what happened, both are coincide, okay, so that may be causes some distortion, okay, that's why here delay line, okay, the delay line will delay the signal sometime here, okay, and send to the vertical plates, okay, so that is nothing but the delay line. Okay, coming to the see, here you have to read delay line. It provides some amount of delay to the signal which is obtained at the output of vertical amplifier. This delayed signal is applied to the vertical deflection plates of CRT. Okay. Trigger circuit. Trigger circuit means it produces a triggering signal in order to synchronize both horizontal and vertical deflections of electron beam. Okay. Trigger circuit means to energize that electron beam, it produces some signals, okay, that is nothing but the trigger circuit. Time based generator, it produces a sawtooth signal which is useful for horizontal deflection of electron beam. Okay, see here time horizontal to see here, coming to the diagram. See here horizontal plates, the horizontal plates are working through a trigger circuit, okay, time based generator, horizontal amplifier. Okay, see here you have to giving the signal to the vertical amplifier through vertical plates, through horizontal amplifier you have to given the signal to the horizontal amplifier. So and the electron beam will comes, electron beam is nothing but some magnitude. Okay, so at that time here the signal will be moves up and down here to and fro, and finally you have to display here. To supply this horizontal plates, here you have to use a trigger circuit. Okay, this is generate signals. Okay, so through time based generator and horizontal amplifier, here you have to giving the signal to the horizontal plates. See, time based generation, it produces a sawtooth signal which is useful for horizontal deflection of electron beam. Okay, that means the electron beam deflected horizontally. So at the time for this deflection, so it needs some voltage. Okay, that voltage will provided by producing a sawtooth signal by using the time based generator. Okay, horizontal amplifier, it amplifies the sawtooth signal. Okay, sawtooth signal, and then it connects to the horizontal deflection plates of the CRT. So here the time based generator will produces the sawtooth signal. Okay, that signal is again amplified. Amplification is nothing but again it increases the strength of this signal. Okay, sawtooth signal, and giving to the horizontal amplifier. Okay, so power supply. So why you need here power supply? It produces both high and low voltages. Okay, so it produces the negative high voltage and positive low voltage are applied to the CRT. Okay, here it produces high and low voltages, and high negative voltage and low positive voltages are used to apply the CRT. Okay, cathode ray tube, it is the major important block of CRO. Okay, already here you have to discussed. Okay, so CRT is nothing but it is the major important block of CRO. Okay, so and mainly consisting of four parts. Okay, it is mainly consisting of 4 parts. Those are what are electron gun, vertical deflection plates, horizontal deflection plates, and fluorescent skin. Okay, already you have to see. Okay, see, this is again you have to cathode ray tube construction. Okay, here supply. Okay, cathode. Okay, this is control grid, this is the accelerating anode, This is focusing anode. Okay, these are Y plate. Y plate is nothing but the vertical deflection plates. X plate nothing but horizontal deflection plate. That means up to now here you have to the electron gun. Electron gun means here you have to produce the electrons, and this one is deflection system. That means here you are using the vertical deflection plates and horizontal deflection plates. Finally, this is a fluorescent screen. See here the accelerating anode and focusing anode. Okay, here under control grid. See, whenever here it emits the filament, here you have to using a one filament. Here you have to give it a 16 volts AC. So at that time it releases the cathode. Okay, cathode. So this is a cathode. Okay, cathode filament. So at that time, whenever you heated this cathode, this emits the electrons. Okay, and these electrons and this way these are passing the control grid, focusing anode, accelerating anode, okay, horizontal deflection plates and vertical deflection plates. Okay. See, here why you are using the control grid means, see, whenever you here the cathode filament will emits the electrons continuously. At that time, whenever at a time all the electron beams are displayed on displayed on the CRO. So at that time it is difficult to take the amplitudes. Okay, that's why here the control grids will control the emission of electrons from this cathode. Okay, so accelerating anode. Accelerating anode means so that means these are the that means accelerate the speed of the electron beam. Focusing anode means this focusing anode will be makes the electron beam will be focused on the fluorescence key. Okay, so you know vertical deflection plates will move up and down, horizontal deflection plates will move to and fro, and finally here the electron beam will be displayed on the fluorescence key. This total is called deflection system, this total is called electron gun. This is the operation of a CRT. Okay, deflection sensitivity of CRO. Okay, see here deflecting plates. Okay, see whenever you have to take near two deflecting plates. Okay, so that is the horizontal and plates. So this is a screen. See here electron beam. I will say that electron beam. See here, this is the straight portion. Okay, like this. So measure straightly here. Okay, this is the deflection sensitivity of the CRO. See here. Okay, so this is the operation of CRO. Okay, so so later topics we are discussed in next class. Okay,